Hello. This problem 6.71 is a little modified compared to the textbook. It states, show that for a rotating cylinder in a uniform flow, the following pressure ratio equation is true, which is pressure at the top minus pressure at the bottom of the cylinder divided by stagnation pressure minus the free stream pressure equals 8Q over U naught, where Q is the peripheral speed of the cylinder due to rotation of the cylinder only. So we can express, this is the problem with potential irrotational problem, regardless of the fact the cylinder actually rotates. So we can use the strong form of Bernoulli equation at all points of the field. So we'll basically state that stagnation pressure is equal to the total pressure in the free stream plus dynamic pressure due to velocity U naught squared, rho U naught squared half. And this is also equal to pressure at the surface at any point of the cylinder plus rho US squared over 2, where US squared is the velocity at any point of the cylinder, which varies with theta. So we can express that as PS plus rho half of, and the velocity is given as the sum of velocity due to flow around the stagnating cylinder, which is minus 2 U naught sine theta, plus velocity due to rotation, which is G over 2 pi A, where A is the cylinder diameter squared. Now, we are also told that we have the peripheral velocity given as Q, but by definition G over 2 pi A is the peripheral velocity of the cylinder. So we can replace this whole term by Q. Then also, as we move, we want to solve this for PS. So using this equation and this equation here, we say that PS is equal P naught plus rho U naught squared half minus rho half of minus 2 U naught sine theta plus Q squared. And it'll be helpful for us to expand this, so we have P naught plus rho U naught squared half minus rho half of 4 U naught squared sine squared theta minus 4 U naught sine theta Q plus Q squared. And now we use this expression for the top point and for the bottom point. So for the top point, we have theta equals pi half, sine theta is 1, then we have P top equals P naught plus rho U naught squared half minus rho half of 4 U naught squared minus 4 U naught Q plus Q squared. And then for the bottom, we have theta is 3 pi half, sine theta is minus 1. So we have P bottom equals to P naught plus rho u naught squared half minus rho half of 4 u naught squared sine squared. Square of minus 1 is still plus 1, but we have plus 4, sorry, we don't need, this is 1, we don't need it here. So we have 4 u naught q plus q squared. And now we can form the ratio p top minus p bottom, or p stagnation minus p naught. It's going to be equal to well, let's write the whole thing, although obviously these two terms cancel out, but just for completeness, p naught writing top plus rho u naught squared half minus rho half of 4 u naught square minus 4 u naught q plus q squared minus p naught plus minus rho u naught squared half plus rho half of 4 u naught plus 4 uq u naught q plus q squared. And all of that divided by p naught plus rho u naught squared half minus p naught. So here p naught cancels out, rho u squared cancels out, and given that this is plus this expression minus this plus this, so all the terms with the same sign inside the brackets cancel out. All we're left with was basically now p top minus p bottom, or p stag minus p naught equals to rho u squared 8 rho u squared u naught squared sorry, not squared, rho u naught q, or half, divided by rho u naught squared half, which is equal to 8 q over u naught.